Hello and welcome. For the today's topic, I am going to explain some concepts regarding quadratic equation. Here in this video, I am not going into much detail and the depth, but I will explain the concepts related to quadratic which are sufficiently required to understand what are the quadratic equations about, how we can use these concepts for solving the questions in JEE Mains or Advanced and in other places also. So let's say before defining quadratic equation, I would like to define a polynomial. So what is a polynomial? Polynomial is basically an equation where y is equals to, let's say, a0 x to the power n, a1 x to the power n minus 1, say a2 x to the power n minus 2, and so on up to an minus 1x and an. So basically this is called a polynomial. There are multiple terms, hence polynomial means many terms, and the power or the degree of x is decreasing order, is in the decreasing order. So this is a standard form of polynomial with degree. This is a polynomial having degree n. So for this equation or this polynomial to have degree n, we must need this term. So since we need this term, that means it should be present there. If it is present there, this cannot become 0. This cannot become 0. It means also that the first term or the coefficient of x to the power n should not be equal to 0. So if we define these two things, then we can say that it is a polynomial of the degree n. Now, for a polynomial, we have just only said everything about the power of x and a0 not being equal to 0. What we can say about the values of a? A can take any value, a, b, c, d, e, f, g, h, or 1, 2, 3, 4, plus 1, minus 2, minus 2. It can take any values. So based on this, we can define a quadratic. A quadratic equation is or more accurately, I say quadratic relation or expression is, let's say, it has highest degree, or it is the equation of degree 2. It should have highest degree 2. That means we should have y is equals to, let's say, ax square plus bx plus c, and obviously, as I said, for this equation to be a quadratic, the x square must be present there, and for x square to be present there, a should not be equals to 0. So using these two conditions, we can say that the given equation is a quadratic equation. And also remember that I have only talked about the power of x. I have said nothing about a, b and c. Here values of a, b and c can take any value from real number to complex number. So because in complex number we already have two parts, either real parts and imaginary parts, so therefore we can say that if a, b and c belongs to complex number, by default it means that the real numbers are also included. Okay, so this is the basic definition of a quadratic relation or equation. Now what happens that here the values of x, we can take any value in the domain. The value of x we take in any value in the domain of the x. Now when we take value of x from the domain, usually the domain is defined as the domain is equals to real number. That is for all values of x in real number. Why? Because when we plot the graph, we usually take x-axis as a real axis and y is the imaginary axis if we need it. But we usually take x is a real axis. So therefore, the domain of the x is real numbers. Now, what happens that whenever you take some input of the x-axis, from the x-axis, we get a value in y, that is your output. And when we take the point x comma y, we get a graph. And for any quadratic, the graph is basically a parabola. I am not going into the detail of the parabola, but basically either it is going downwards or it is going upward. It is a curve, second degree curve. We call but their power is 2. Now, this is the basic information regarding quadratic, where we have just said that y is equal to ax square plus bx plus c is a quadratic relation where a should not be equal to 0 and the values of x are from the domain, which is usually real number, right? Now, for it to be a equation in quadratic, it should have some values. Equation necessarily means that some value is equals to some other value. This is a relation, y is related to x. For equation, the some value should be equal to something. So when the equation takes the value ax square plus bx plus c equal to 0, then we can say that for some values the value of x becomes 0. So for some values of x, this relation becomes 0, that is y equal to 0, and y is equals to 0 is very interesting, because at y equal to 0, we know that y is 0 for which axis? Only for x axis. So we can say that when the graph, or basically parabola, but in general we can say when the graph of any equation or relation f of x equals to y cuts x axis, that is y equal to 0, then at those points, it may be singular, it may be plural, then at those points y equal to 0, f of x becomes 0, that is those are called the roots of the equation. Those are called the roots of the equation. Roots of f of x. Okay, let me say that. For any values of x, we get the value of y. When we get the point x comma y, we plot a graph and it becomes a parabola, either going upwards or going downwards. It can be any, depending on the values of a. Obviously, I am not going into the parabola. But when the y is equals to 0, this whole expression or equation becomes 0. When this becomes 0, that is y equals to 0, means y is 0 at x-axis. So whenever that graph cuts the x-axis, it implies that y equal to 0, and at that point the function becomes 0. When the function becomes 0, it is called root of the equation. For example, let us say this is your parabola and this is your x-axis. Okay, if you can draw it inverted also. So at this point alpha, at this point beta, or at this point alpha, at this point beta, what we are getting? The graph is cutting the x-axis, that is y equals to 0. That means the function at alpha equals to 0 or function at beta equals to 0. Same, or you can put value of alpha in the equation, that is a into alpha square plus b into alpha plus c equals to 0, or you can say a into beta square plus b into beta plus c equals to 0. For these two values, the value of the graph becomes 0 or it cuts the x-axis. Therefore, alpha and beta are roots of the equation. F of x equal to 0. Equal to 0 is necessary because then it becomes equation. Let us suppose if it just touches the graph, then it doesn't matter if it touch or cuts, because at this point also or at this point also it is touching the x-axis. So at this point the value of y is 0. So for this condition also y or f of alpha is equals to 0. So again we can say that therefore alpha is root of f of x equals to 0. Now here I would like to clear something. First, remember that the domain of x is real number. So whenever the graph cuts the axis, we get the roots, and these roots lie on the real number. So therefore the alpha and beta, when we say the roots of the equation, we are basically talking about the real roots of the equation, because these are the real numbers. So these are real numbers. So roots are real. The roots are real. These are not imaginary. Okay. So we will see what about the imaginary roots also. So just hold on a second. Let me clean up the board. Now another thing I would like to discuss is that for any polynomial, for any polynomial of degree n has n roots. I am only saying about roots. Whether it is real or imaginary, I am not saying. For if it has degree n, then it has n roots. So therefore, for any quadratic, it must have two roots. For any quadratic, it must have two roots. Now, two roots. Now, since it has two roots, we have already seen that we have very different conditions. Let's suppose it cuts this way, so we get two roots, no problem. If it cuts this way, we also get two roots, alpha, beta. So if it touches the axis, the x-axis, the horizontal line is the x-axis, then we only get a single point. But by definition, we say that there are two roots. So whenever we touch the axis, we get both alpha and beta at the same point. So both roots are equal roots. These are equal roots. Here you can say that if I take, let's suppose, if I am taking this graph and just pulling it upward, these points try to shift upward and alpha and beta are getting closer and closer. So at this point, alpha is equals to beta and it touches the x-axis. These are distinct roots, and obviously both are real roots. Why? Because both are cutting the x-axis and values of x-axis are real values. Therefore, these are real roots. But if the graph is not touching or cutting the x-axis, then in this condition we are getting no real roots. Again, look at the words, no real roots. As the roots are not real, but it must have two roots, then if these are not real, then it is obviously imaginary roots. And it has two imaginary roots. Okay, this is just graphical condition that we have seen here. Now we will go to more analytical way. We know that for any equation quadratic ax square plus bx plus c equal to 0, we know that the roots comma alpha comma beta are given by minus b plus minus under root b square minus 4ac upon 2a. These are the two roots that we know. But since if you look at it carefully, and obviously a, b and c belongs to complex number, it can take any values. Okay, a, b and c can take any values. Now obviously this relation holds good for any complex number also. Okay, so you can see here that we have a term that is in the root. So we know that for any value b square minus 4ac, for it to be real, this should be equal to 0, greater than 0. Or if we remove the root, this value should be greater than 0. So if b square minus 4ac is greater than 0, then we get two distinct values. Then we get two distinct values or two distinct roots. We already know what the roots are. So it satisfies the first condition of graph. So if b square minus 4ac is equals to 0, then what happens? This becomes 0 and alpha and beta has the same value, that is minus b by 2a. That is alpha and beta have the same value, that is minus b by 2a, and this is called repeating root or same root. The values are repeated or the roots are repeated. Obviously both are real. This is for the real roots. This condition is for real roots. Next, if b square minus 4ac is less than 0, that means this whole value in the root is negative, and whenever the value under the root is negative, it becomes imaginary. This becomes imaginary roots. This becomes imaginary roots, and obviously you can see that this is imaginary part now for this condition, and as it is imaginary, one time it is plus and another time is minus. When the roots are imaginary, we can say that we get one plus sign and one minus sign. So these imaginary roots always come in conjugate pair. This is very interesting and very important. How it is important? We'll see just after this, and we'll see a question in J Advanced, I think this year also. It came on this concept, conjugate pairs. That is, it will be either two values or no, either two complex roots or no roots. When this is very important. Two conjugate pair is only possible when A, B and C are real numbers. This is important. Two conjugate roots, because suppose we have one real root and one imaginary root. Suppose one real root. I am just taking an example. It's still not over, but let's take an example. We have one root x is equals to 1 minus I, and alpha equals to 1 minus I, and beta equal to, let's say, 3. These are two roots. One is real, one is imaginary. Now let's make up the equation. If you know how to form it, it is minus alpha plus beta into x plus alpha beta equals to 0. This is the quadratic equation. So let's make equation x square minus alpha plus beta. So 1 plus 3 is 4 minus, this is I into x, plus multiply. So 3 minus 3i equal to 0, or you can now write it like this, plus I. Okay, no need to take minus common out. Plus 3 minus 3i equals to 0. This is the quadratic equation basically. Now let's take out the b square minus 4ac value. Okay. So b, this is b. 4 minus I whole square, obviously minus 4. A is 1, C is 3 minus 3i. Okay, let's calculate. So a minus b whole square, this is 16 minus 8i minus 1 minus 12 minus plus 12i. Now let's see why I have said like this. This is 16 minus 12 minus 1, that is 3, and this is plus 4i. Now we got some discriminant like this. We got a discriminant like this, and this cannot be compared with the 0. If you know what the complex numbers are, complex number cannot be compared. We can compare their distances, but we cannot compare their value, because we cannot say that whether this value less than 0 or greater than 0. That's absurd, because 0 is real and this is imaginary. We cannot compare this. So whenever I'm saying that imaginary roots always come in conjugate pairs, what I meant to say that the values of a and b and c should always be real. Only after that we can compare the discriminant. Otherwise there is no point in comparing this value to 0. One is imaginary, one is real. You cannot compare what you think in your dreams and what is the real life. Both comparisons are totally different. It's absurd comparison. So therefore whenever I see that the imaginary parts always come in conjugate pair, that means a, b, c are real, and same case goes to this. Because here we are comparing with 0. So there should not be any complex part, right? Obviously two complex number can form this, but regarding a, b and c, what I am saying, these are the real values. Okay, these are some basic conditions. Obviously here I can also say that b square minus 4ac equal to 0, right? Or this value can take perfect square. If it is perfect square, then the root gets cancelled and I get two rational roots. Okay, I'll just write it there. Like, just hold on a second. Okay, so in continuation to this, only for this, because 0 is neither positive neither negative, we don't care. Same related to this, since it's always negative, so avoiding that. Let's come to this. If b square minus 4ac, about this, if it is a complete square, you know what is complete square is 1, 4, 9, 16. If it is complete square, then what happens? If it is a complete square, then the root will come out. The square and root get cancelled, and what we get, if it is a complete square, then we get two rational roots. Two rational roots. And similarly, if this value is not a complete square, it is not complete square, then we cannot cancel out the root. If we cannot cancel out the root, then there is a value here in the root. That means our roots are, we get two conjugate surds. Two conjugate surds as a roots, and obviously these also comes in a pair. Okay, this is just a part of the analysis from what we are seeing here, because we have seen that the roots, the value of root includes a value in the square root. So the roots have the value something in the square root, and the condition for the square roots are this variety of conditions, right? This is the simple, just a basic understanding about what are the quadratic equations are. It's not over, it's just basic understanding. And regarding equations, I'm also going to tell you a simple concept, what is the identity and how it is used in questions. Just hold on a second. One important thing that I'd like to discuss is the identity. What is the identity? It is basically an expression or equation. It is basically an expression or equation which is true for all values. True for all values. And you have seen some examples regarding this. If you don't remember, let me give you the example. For example, a plus 0 is always equals to a. This a can take any value. A can take any value. You can take any value of this a and you still get, adding 0, the value of a. That means the original identity of a did not change. It was a before, it is a now after this operations also. Obviously, you already have seen this, a into 1 is again a. So again same relation, a can take any value in the complex plane or the real plane, but the value of a do not change or does not change after the multiplication operation. So in these both cases, 0 and 1 act as a additive identity and multiplicative identity. It basically means it is true for all the values of a, additive identity and multiplicative identity, that is 0 and 1. Similar to this, there is a concept called equation or expression, which is also called identity. For example, let us suppose we have an example, let's say x plus 1 whole square. What is the value of this expansion? Is x square plus 2x plus 1, but right now it does not put any equation. You can put any value of x, this equation is always same. You can check it. If I put x equals to 1, suppose if I put, let's say so let's put x equals to, suppose simple one, let's say put 2. So 2 plus 1, there is 3. So 2 plus 1 square is equals to 2 square plus 2 into 2 plus 1. So this becomes 3 square. This is 4 plus 4 plus 1. This is 9 equals to 9. You can check that this relation holds true for any value. That means this is an identity. This is an identity. Now again, the word I would like to emphasize here is that it is true for all values of x. All value of x. This is the most important part. That means x has here values. X has values. So if I take this to back side or transfer this side, or I can say that, let's say I'll expand this one. This expansion is same. Now this is the interesting part. You are saying that I am subtracting same thing from the same thing. I am subtracting same thing from the same thing. That's why it comes out to be 0. But remember that x can take any value. So if this x square takes any value, this 2x also takes any value, and this is 1 minus 1, then you can see here that the coefficient of x is 0, the coefficient of 2x is also 0, the coefficient of something is 0. That means this is most important part, that for any identity, that is for any identity equation, for any identity equation, or better, or we can say that since here values of x are infinite, but for quadratic we only need two roots to be equal to 0, but here are infinite roots. So for any equation, or for any equation or equation of degree n, for any equation of degree n, if it has more than n roots, if it has more than n roots, since we have seen just before that for any polynomial of degree n there must be only n root present, but if there are more roots, that means that it is true for more values of x. If there are more values of x, then it means it is identity. If it is identity, then the coefficients becomes 0. Then the coefficients becomes 0, because for 0 you can put any values here, it will always come out to be 0. It has more than n roots, then it is an identity. This is very important thing. You have to remember that identity is something which is true for all the values of x, and if it is true for all the values of x, that it means that if it is quadratic equation, it has more than 2 roots, then it is identity. If it is a cubic equation, it has more than 3 roots, then also it is identity. If it is to the power 6 equation, it has more than 6 roots, then also it is an identity. By default, it means the coefficient of each term is 0, or the each coefficient is 0. This is the most important point regarding the identity. Now we will see a question which can help you understand how to use these both values, or both the, let's say, both the concepts that we have learned today. Okay, this is a question from JEE Advanced paper 25 this year also, and the given is function defined on real numbers, and also given that a, b and c, any values are a and b values, the ai, bi, this belongs to real values. Okay, all are real values. Now look at here, what we have given. If f of x is not equal to g of x, both are not equal, that definitely means the f of x minus g of x is not equal to 0, right? Is not equal to 0 by this condition. Now if two things are equal, then the subtraction is 0. If both are not equal, then subtraction is not equal to 0. It's very simple. So using this, I will just subtract this. So what I get, f of x minus g of x, and if you simplify, I get a1 minus b1 plus 10 minus 3, 7x, plus a2 minus b2 x square, and a3 minus b3 x cube, and x will get cancelled, right? This is the simple f of x minus g of x. It simply means that since f of x minus g of x is not equal to 0, that means the given expression, that is a3 minus b3 x cube plus a2 minus b2 x square plus 7x plus a1 minus b1 is not equal to 0. Okay, now this we know. This is the given condition that we know. that this is not equal to 0. Now since this is not equal to 0, it can only mean it does not have any root. Since it is not equal to 0, it means there are no roots. Obviously no real roots. There are no roots, that means no real roots. This is most important part. These are not real roots. Sorry, not real roots. There are no real roots. Why no real roots? For real root, the graph has to cut the x-axis, and when it cuts the x-axis, there is at least one value of real x-axis. So if it does not have real root, it only means that it has imaginary roots. It has imaginary roots. Okay, that you also know. Now since it has imaginary roots, we know that imaginary roots always comes in pair. Always comes in pair. So if it comes in pair, so either we have two roots imaginary, or we have four roots. Either we have two roots or we have four roots. Either two or four, because these are only imaginary roots. They only come in pairs. But here the highest power of the equation is cube. So it has three roots and no real root is present. That only means there are only two roots possible, no four roots, since there is no power. Okay? Because it has degree 3. So therefore it is only possible that there are only two roots. So as there are only two roots, that implies that the third root is not possible. If third root is not possible, that can only mean that this equation is actually a quadratic. This implies that the equation is quadratic. And for equation to be quadratic, the power of the coefficient of x cube should be equal to 0. So therefore, which also implies that the coefficient of x cube should be equal to 0, which also implies that a3 minus b3 equals to 0. This is the most important conclusion that we have drawn. What we have did, since both are not equal, therefore the subtraction is not equal to 0, and this whole equation does not equals to 0, so it does not have any real roots, because it is never becoming 0 for any value of x. So if it does not have any real roots, so it must have imaginary root. But imaginary root always come in pair, either 2 or 4, but 4 is not possible. Why? Because the highest degree is 3, so only 3 roots are possible, but we can only get 2 roots. That means the third root does not exist, or third root is not possible. That means the given equation has 2 roots and it is a quadratic. For this equation to be the quadratic, this coefficient should be equals to 0, and we get the relation a3 minus b3 equals to 0. Now, the second condition given that h of x, we need the coefficient of x cube. Now let's expand h of x. So f of x1, put x1 at the place of x. So f of x plus 1. So I'll just write this is a1 plus 10 times x plus 1, okay, plus a2 times x plus 1 square plus a3 times x plus 1 cube and plus x plus 1 to the power 4. I am just writing this to explain. Okay, g of x plus 2, I guess. Okay, again b1 plus 3 times x plus 2 plus b2 x plus 2 whole square plus b3 x plus 2 whole cube, and this is x plus 2 to the power 4. It should be power 4. Now remember what we have been asked here, only the coefficient of x cube. So we need the terms of x cube only. We don't need the whole thing. So where is x cube? Here no x cube, no x cube, highest power is square. So here only possible x cube. Here is only possible x cube also in this expression also. Okay. So let's find. This is x cube. When we expand x cube, so this becomes a3 into x cube plus. Now in this situation, we can use the coefficient. Which coefficient? Binomial coefficient. We need x to the power 3. So total is power 4. C, we need x power 3. So x power 3 into 1 power 1, right? Simple. Okay. Minus. Now here check this out. Similarly here b3 into x power 3 plus same condition here. There is a 4c3 x power 3 2 power 1. Okay, now just put the values. A3x cube plus 4c3, I guess it is 4x cube, minus again b3x cube, sorry, plus into 2 minus 4 into 2 into x cube, and the coefficient, we just have to find this coefficient value. Okay, now we'll take the value common. There is also x cube, x cube, x cube, so this becomes a3 minus b3 into x cube, and this becomes 4 minus 8x cube. a3 minus b3 is 0. Here we have found that a3 minus b3 is 0. 4 minus 8 is minus 4 x cube. So therefore coefficient of x cube is minus 4. It was such a simple equation, simple question, that we could have solved this just based on the two information. One, when the equation becomes identity, and the number of roots. Number of roots are equals to the degree of the equation. Here the degree is 3, but the root can be possible only either 2 or 4. 4 is not possible, cannot be higher degree. So lower roots are possible. So 2 roots are possible, therefore the third root does not exist. That means for this value, the coefficient of this should be equals to 0. And it's very simple application of quadratic equation. I hope you understood what I would like have to discuss. If you have any questions regarding this, you can put it in the comment. Let's see if you have any doubts. And regarding other topics on this quadratic equation, we will see further as we progress. So, okay. So, take care. See you soon.